And we're back. Welcome back to College Algebra. I am Paul Walcher. This is the second video of our look into P8. We're going to start off by looking at some examples. We're going to solve some equations. Let's get to it. Alright, our first couple equations are just going to be linear equations. Not a lot of work to them, but we'll introduce new elements as we go. This first one, pretty typical. Remember our set of steps. We start out by getting all of our variable terms on one side, getting all of our other terms to the opposite. So let's say we want to solve for t on the left. So I'd want to move this negative 5t over. So we'll add 5t to both sides. And I'll move the 13 to the other side too. So plus 13 plus 13. So this will get me 10t equals 25. And then I divide out the 10, have t equal 25 over 10. And that would be, oh, I guess I should reduce that. That'd be 5 over 2. That's fine as your answer. Also, since that's an exact decimal, it would be fine to say 2.5. As far as checking, this wouldn't be too hard to check by hand. Generally, I check things in the calculator, but this one I might as well make an exception to. 12 minus 5 times 5 halves. Looks like I'm going to have to get common denominators. That'll be 25 over 2, 13 over 1, 12 over 1, minus 26 over 2. That'll be negative 1 half. And this one will be 24 over 2, minus 25 over 2. Oh yeah. Both sides I would get negative 1 half. So the equation is equal, and that verifies that this is a solution. Here, there's really two ways of approaching this problem. You can just work it as it sits and do fraction math. This side, just so we have a common format, that's 1/5 z equals 3/10 z. Plus 7. Well, I need to get all my variable terms on the same side, so I subtract that 3/10 z from both sides. By the way, it's perfectly fine to solve for something on the right side. It doesn't have to flow left to right. And if you move something to the right side, it's perfectly fine to switch the sides of an equation. I could write this 3/10 z plus 7 equal 1/5 z. It doesn't matter which side is which, as long as you don't arbitrarily change the terms. So if I switch the sides, 3/10 z plus 7 still has to equal 1/5 z, whether it's left to right or right to left. But now I have to figure, I should combine this side, and I'll just do it down here. I have to get common denominators, so 2 times 2 times 2, that would be 2/10 minus 3/10. So I would get negative 1/10 z equal 7. And then I want to solve by dividing out negative 1/10 from both sides. Dividing by a fraction is the same thing as multiplying by the reciprocal. So I have z equals 7 times negative 10 over 1. So that's negative 70. Now, how my students typically do this is that they will clear fractions. To clear fractions, you find the least common denominator. Which in this case would be 10, and you multiply it into both sides. Times 10 times 10. Now on this side, it'll be pretty simple because you can reduce 1, 2. So I'll have 2z equals. On this side, I got to distribute through 10 times 3 over 10. The 10 will reduce, and I'll just get 3. So 3z. 10 times 7 is 70. And now, all the fractions are gone, so I just need to solve it like I did the last problem. Negative z equals 70. Divide out the negative 1. Z equals negative 70. Well, let's go with blue for a while. So there you have it. This is our first equation that isn't linear in form. But as we'll see, it will lead to a linear equation. So the first thing I'm going to do is I'm going to remove these parentheses by multiplying them out. So if I do that, let's see, I've done a lot of binomials at this point. X times x, x times 2. It's going to be x squared plus x minus 2. It's kind of factoring in reverse. I know the middle term is going to be 2x minus x. So 2x minus x is just a single x. And the other side will be x squared minus 2x minus 3x, so minus 5x. And then negative 2 times negative 3 plus 6. Still not linear, but if you'll notice, first thing I probably want to do is try and move either all the variable terms to one side. So if I try to move the x squared either left to right or right to left, I do the same thing. Subtract x squared from both sides, and when that happens, it goes away. So now I'm left with just x minus 2 equal negative 5x plus 6, and that's a linear equation. So this time I think I will solve for x on the right. So I will move my x to the right, and I'll move my 6 to the left. That'll leave me with negative 6x equals negative 8. Divide out that negative 6, and I will get 4 over 3 equals x. Here, another equation that's not linear. Now this is an equation that we can still solve by the basic process, though. It's just in here we have to clear the fractions. It's not optional because the variable's on the denominator and we need to solve for the variable. So the first thing I need to do is clear the fractions. So to clear a fraction, you have to find the least common denominator. Now since we got rational expressions now, to find the least common denominator you're going to have to dig back in your head to the last section. To do that, we factored all the denominators. So I'll factor this one. I'll get 2 times x minus 2. And you build your common denominator by putting all the pieces you couldn't factor any further. Couldn't factor 2 any further, so you have that. Couldn't factor x minus 2 any further, so you got that. And that's all the prime factors, so I take my least common denominator, and just like I did in the last problem, I multiply it through. So I've got x over 2x minus 4. 2 times x minus 2 is better. Minus 2. All of this times 2 times x minus 2 equals 1 over x minus 2 times 2 times x minus 2. And I'm just doing this over 1. The reason we do this is it will reduce away all the denominators. When I multiply into the first term here, the 2 will reduce, the x minus 2 will reduce, and I'll just be left with x. Multiply into the second term, nothing to reduce, so I'll just have the 2 times that, so it'll be minus 4 times x minus 2. And on this side, the x minus 2 will cancel out, and I'll just be left with 2. Now I've got a linear equation. So if I solve this, multiply the negative 4 through, minus 4x plus 8 equals 2. Move the 8 over, combine those two, I get negative 3x equal negative 6. Divide out the negative 3, divide out the negative 3, get x equal 2. Now, that's not actually the answer, because if you check this, plug it back up here, this is undefined, 1 over 0, and so is this. The equation isn't true if you have an undefined on either side. So this cannot be a solution. So that means we have no solution. That's something you should always do when you're looking at a rational equation, an equation that has rational expressions in it. When you get the answer, make sure it doesn't make one of your fractions undefined. This is called an extraneous solution. We went through the correct process and came up with a possible solution, but it didn't actually work in the original equation. So keep that in mind. You get rational expressions, you're going to need to at least do a rudimentary check to make sure it doesn't make one of the denominators go to 0. Not all rational equations have that problem. I believe 52, the next one we're going to look at, we come up with just one solution. Looking at it here, we want to clear the fractions, so to do that, first off, we have to know what they're all factored out to be. X squared minus 9 is a difference of squares. So I think this will be our least common denominator, because it has all of our prime factors, and they all had at most a power of 1. So we'll start off with that. Clear fractions here. X plus 3, x minus 3, equals 2 over x minus 3. And we're multiplying the left side by x plus 3, x minus 3, and the right side by x plus 3, x minus 3. The left side on the first term, the x plus 3 will reduce away, and I'll just have x minus 3. On the second term, both will reduce, and I'll just have that 5. And over here, the x minus 3 will go away, and I'll just have 2 times x plus 3. So I have x plus 2 equal 2x plus 6. So move the 2, move the 2x, have negative x equal 4, so x equals negative 4. And that's fine as a solution. The only numbers that would have given me problems would have been if I would have got positive 3 or negative 3 as my answers. Since I didn't get those, this should be fine as a solution if I did all my work correctly. I suppose it's not terribly difficult to check this one. I might as well do it. 1 over negative 1. I will try to do some calculator demonstrations at some point. Plus 5 over, let's see, that would be 16 minus 9 equal 2 over negative 7. Is that right? Negative 4 minus 3? Yeah. So that would be negative 1 plus 5/7. And that's negative 7/7 plus 5/7. So that'd be negative 2/7. And yeah, I'd have the same thing on both sides. Alright. Now we're finally looking at power equations. So jumping back to our PowerPoint just for a second. The key to solving power equations is that you can take an nth root of both sides. The only thing you have to be careful of is if you take an even nth root, you will get this positive negative showing up. So for example, if I had x squared 9, there are 2 square roots of 9. Positive 3 and negative 3. So we usually abbreviate that with positive negative, but it does denote 2 solutions. And when you put it in on WebAssign, you probably will have to write both. One will be 3 and the other will be negative 3. And that would be the same if I had a 6th root as well. Took a 6th root of something like, it doesn't have to be a perfect 6th power, so let's say 13. X would equal plus or minus the 6th root of 13. So let's do some power equations. These don't take very long because you solve them like linear equations. You just have to do this root process at the end. So x squared minus 7, if I want to solve that, I just isolate my x squared. So I get my x squared alone on its side, so add 7. X squared equals 7. And then I take a square root of both sides. X equals plus or minus square root of 7. Boom. Done. If you have a parentheses raised to a power, no different. You solve for your power expression here. Solve means isolate on a side. So I'm going to get x plus 2 by itself. I'm going to take a 4th root of both sides. Remember, if this had been a negative 1, you could have stopped then because not a real number. We'll do some problems where we take roots of negative numbers, even roots of negative numbers later in the book, but for right now we're not prepared for them. So x plus 2 equals the plus or minus the 4th root of 81. 81 actually is a perfect 4th power. You'll get a 3, plus or minus 3. So my final answer, I move the 2 over. Don't try to combine it yet, because you get 2 answers. One of them is going to be negative 2 plus 3, and that's 1. So that's one answer. The other is negative 2 minus 3, which is negative 5. So don't try and subtract 2 from both sides and say it should be plus or minus 1 now. No. You have to evaluate each one separately. This one I wanted to do not because it really illustrated anything new. It's just because it had an odd exponent instead of an even one. I suppose there are some new things in it though. You want to solve for x. We want to get rid of this power, so we got to isolate this power expression on the side. So we got x plus 2 to the 5th. Divide out the 4, I have 1/4. 5th root both sides. I have x plus 2 equals the 5th root of 1/4. Note, I do not need a positive negative because this is an odd root. It's only one odd root of every number. Move the 2 over. Negative 2 plus the 5th root of 1/4. And I might rationalize the denominator of that because that's plus 1 over the 5th root of 2 squared. So negative 2 plus, have to multiply by the fifth root of 2 to the third, fifth root of 2 to the third. So that would be the fifth root of 8 over 2. I think that's enough for this video. We'll finish out the section next time where we will do some general equations. It'll probably be a shorter video.